Okay, so guys, okay, continue with example 5.19 here. Okay, so use Taylor's theorem. Okay, Taylor's theorem. So why we use Taylor's here? Okay, because the expansion that it asks you is cos x with plus something, right? Pi over 3. So pi over 3 here is actually your a. Okay, because previously it asked you to find cos x or maybe cos 2x, get expansion of cos 2x. Okay, but now when you have cos x plus something, so this is your constant, okay, the center, okay, your value of a. So a is equal to pi over 3. So basically, again, basically the formula, the steps are almost the same. Okay, so you find the expansion as we have learned before. Cos x. Okay, so cos x is equal to a naught plus a1x plus a2x squared. And then you solve for a naught, a1, and a2. Okay, once you have that value, okay, and then how about this value? Okay, so if you refer to the Taylor series definition, okay, Taylor's theorem. Okay, so we have this formula, right? So f of x plus a is equal to fa plus x, okay, the first derivative, and then plus with x squared, the second derivative, plus x cubed over 3 factorial. So this one is the third derivative, okay, plus in the fourth derivative, have x to the power 4 over 4 factorial, okay, and plus dot dot dot. Okay, so for x plus a, okay, for x plus a, okay, you can start with, okay, like cos x, okay, that we did here, okay, previously, x plus a 2x squared plus a 3x cubed. Okay, and then you differentiate, and then when x is equal to 0, so you have the value of a naught, a1, a2, a3. Okay, and then all the differentiation, okay, you have to substitute your value of a. Okay, you can do this way, or okay, you directly use this formula. Okay, so from this formula, you have to find your fa. Okay, so the function is cos x plus pi over 3. Okay, so what is the value of cos? What is the value of fa when you substitute a inside your function? Okay, and then the first derivative. Okay, and then the second derivative. Okay, the third derivative. So you have to first differentiate. Okay, so differentiate fx lah, which means that fx is only cos x. Okay, so fa here. Okay, what is fa? So this is cos. Okay, from here we have fx plus a. Okay, so fa is what? Your original function. Okay, and then you substitute with a inside your x. Okay, and then the first derivative substitute with a. So your fx is actually cos x. And so fa substitute pi over 3. So cos pi over 3 sama dengan berapa? Okay, so cos pi over 3 is equal to 1 over 2. And then the first derivative. So differentiate cos will give you negative sine x. So when you substitute a is equal to pi over 3, so this will give you negative sine pi over 3. Okay, sine pi over 3. If you can remember, just look at, refer back to the graph. Kan? Ataupun macam mana? Let's say if you have remember by using a table that from your previous study. Okay, so use that. Okay, negative set 3 over 2. Again, then the second derivative. You differentiate again sine. So negative cos. So substitute. Okay, so a here is pi over 3 lah. Okay, second derivative pi over 3. So this is equal to negative cos pi over 3. Okay, cos pi over 3 is half. So negative cos pi over 3 is equal to negative half. Okay, and then okay, so it asks you to find up to the first 5 derivative. Okay, so sampai 5 lah. This is just up to 4. So you have to add one more. So x5 over 5 factorial f a plus dot dot dot. Okay, so the third derivative. Okay, so this one, differentiate negative cos sine. Baru 3 kan? So yang keempat, so sine is cos. Okay, and then fifth, negative sine x. So just substitute pi over 3. So negative, sine pi over 3. So sit 3 over 2. Okay, f 4 pi over 3. So cos pi over 3 again, 1 over 2. Okay, so repeat it here. F5 pi over 3 is equal to negative sine pi over 3. So again, you have this, so negative set 3 over 2. Okay, so once you have this, you just write as in expansion. Okay, so your expansion for this x plus pi over 3 is equal to, okay, just follow the definition of your Taylor series. So FA is 1 over 2. So 1 over 2 plus x. Minus lah, since we have negative, right? So negative. So let me erase first. So negative minus 3 over 2x. Again, and this is also minus. So minus x squared over 4, right? Again, then plus with 3 over 2 x cubed. Again, then we have 3 factorial. Okay, so okay, you should simplify after this. Okay, this is multiply. Okay, so up to here, right? Okay, and then plus with 1 over 2 x to the power 4. Is that right? Okay, x to the power 4. And here's me. Okay, so x to the power 4 over 4 factorial. Okay, plus x to the power 5 over 5 factorial. F, so ni minus. Okay, so ni minus So minus. Okay, so this is how you write. And then we have set 3 over 2. Okay, so we have a few. Okay, please don't stop there. You have to write plus dot. Okay, so this is the expansion for. Okay, this is the expansion for cos x plus pi over 3. Okay, and then it asks you hence. Okay, hence, where is hence? Hence find cos 62. Okay, so what is cos 62 in radian? Cos 62. Okay, so basically when it used the word hence, okay, you have to use the one that you got earlier. Okay, by solving this, surely by using this, okay, please solve this. Okay, please solve this. So cos of 62 is equal to, okay, you have to write in terms of plus pi over 3. Okay, so just check your calculator. 62. So this is okay, this is equal to cos pi over 90 plus pi over 3, right? Okay, so pi over 3, we already have that. Okay, so now this is actually the value of x. So by using this, just substitute pi over 90 inside your x. So set 3 over 2. Okay, your x is pi over 90. Okay, and then minus, so x here is pi over 90 squared. And then over 4. Okay, so multiply with 1 over 4. Okay, you solve that. Okay, up to the 5th term. Okay, plus, and finally, you should get 0.5675. Okay, which is the same as answer provided in the lecture note. Okay, this one, okay, 4695. Okay, so I hope that is clear for that part. Okay, example 5.20. If y is equal to ln cos x, show that. Okay, so we have another differentiation question here. Okay, show that d2 y dx2, which is the second derivative of your y plus 1 plus dy dx squared is equal to 0. Okay, so you have to find dy dx in the second derivative. Okay, and then please show this. Okay, hence, okay, use the word hence. Hence, by differentiating the above expression several times, obtain the Maclaurin series of y. Okay, let me copy this. So again, okay, in this question, it can ask you to find the Maclaurin series. So how? Okay, so since you have find the differentiation, so it is easier for you to find the Maclaurin series, because in Maclaurin series, we have to differentiate few times, right? Okay, so let's together example 5.20. Okay, so from here, your function is y is equal to ln cos x. Okay, so what is your dy dx? Okay, and then what is your d2y dx2? Okay, so try this. Okay, and then show this. Okay, once you have dy dx, you already have the second derivative. So maybe if you want to differentiate one more time, so you just differentiate this. You just differentiate this several times, and then it asks you to find the Maclaurin series of your y. Okay, in the ascending power x up to the term containing x power 4. Okay, so which means that, okay, this is the formula. Fx is equal to f, okay, Maclaurin, so Maclaurin series A is always 0, plus x, okay, the first derivative, plus x squared over 2 factorial, the second derivative, again, then this is 3 factorial, f, the third derivative, 0, okay, up to term containing x to the power 4. So something like this lah. 4, okay, 4 we write this way. Okay, so first and second is already solved here. Okay, you just substitute when x is equal to 0. Okay, and then third, fourth, okay, you have to differentiate 2 more times. Okay, so I share with you the final answer here. So you will have negative 1 over 2x squared minus 1 over 12x to the power 4. Okay, just 2 terms. Okay, so that will be the answer for example 5.20. Okay, so I will continue with the next subtopic, okay, in the next video series. Okay, thank you.